share so that it's the whole page. Okay. And get my, oh, sorry. All right, there we go. All right, so we have an exponential function warm up here for today. So I'm gonna call on you guys to help me finish this. This is honors to be. This is the warm up for 10/6/2020, and this is NC Math 3. Okay, let me close these blanks a little bit. All right, it says Jennifer buys a car for $7,500. She has read that says appreciate by about 10% per year. So for A, ask us to write an estimate to modeling the situation. So if you'll remember when we write exponential function, we have to identify an S, an initial value I, a rate R. Okay, so we need to identify all of those things. So Mark, can you help out with that? Marquez?
Yes, ma'am.
All right. And it's okay to say no. If you don't think there is a number there that represents the final amount. Marquez? Marquez, can you find a final amount for me? Are you here?
Your mic keep cutting in and out. I can't really understand you.
I'm sorry. Can you find this value right here? I'm getting messages from everybody saying my mic is coming in. I'm gonna leave the meeting and come back and see if that helps. Okay, hold on. Okay, are you guys still here? I tried to leave the meeting.
Yes.
Okay, good. So I tried to leave the meeting and come back. Can you hear me any better?
Yeah.
Okay, all right. All right, so Marquez, we were chatting about, and let me reshare so that you guys can see everything again. Just give me 1 minute. I'm sorry, Microsoft Teams. Y'all, I might switch to Zoom, to be honest. This is ridiculous. Okay. So can you guys see both the warm up and my document camera now?
Yes.
Hopefully you hear me better. So Marquez, if you could give me the final value, it doesn't have to be a number. It could be a variable if you don't think a final value number has been given for this particular problem. And I know that my Teams thing is in the way right now. I'm trying to let people in, sorry. Y'all, this is such a mess. Okay. All right, hopefully everybody got in now. Okay, so Marquez, are you still there?
Yeah.
All right, so can you give me a final amount for this equation that we're writing?
Will it be 7,500?
So that's what she buys the car for, so that's actually going to be our initial amount. Does it give us a final amount?
No.
No, so what do we usually put here?
F or A?
We usually use a Y to represent like the beginning of our function, the output. What's the rate that it depreciates by?
10% each year.
Perfect. So I'm going to write that as 0.10. And then time, does it give us a specific time for part A?
No.
No. So what variable do we use for time?
You can put X or T.
Yeah, good. We can use X. We usually use T. Perfect. So now we need to stick this all together. Thank you very much, Marquez. I appreciate it. Navre, are you here? I don't think Navre was here today. Rashani, are you there?
Yeah.
Can you stick all this information together in a formula for me?
Y
Uh-huh.
is it equal?
Yep.
7,500
Perfect. And we're going to multiply by something.
times 10.
Not quite. So we're going to do 1, and then we're going to do minus because it's depreciating, and then we put this 0.10. What's the exponent going to be?
T.
Perfect. Thank you very much, Rashani. Excellent. So part A asks you to write an exponential function modeling the situation. And this is what everybody should have gotten for part A. Okay. Now in part B, it says use your function to find the value of Jennifer's car after 8 years. Daisy, are you here?
Yes.
So what am I going to sub into this function to try to find the value of the car after 8 years?
You'd switch T out for 8.
Perfect. So I'm going to have y equals 7,500, 1 minus 0.10, and I'm going to switch my T out for 8. All right. So now I want to figure out what this is. Okay, so you can use Desmos for this. So I'm just going to type in 7,500 and then times 1 minus 0.1. And then I'm going to raise that to the to the 8th power, excuse me. And it gives me my answer down here at the bottom. It doesn't appear that you can see it for me. Maybe if I just hold it up. So it's not great. So, but your answer will just come right below it. It'll have equals. And this should end up equaling $3,228.50. Okay, as your final answer. Okay, what questions do you guys have on that warm up? I'm impressed. You guys are doing very well with this. Okay, well, thank you, Marquez, Rashani, and Daisy for helping me out with that. You guys did a great job. All right, so today we are going to finish up some of the applications that were on the back of our notes yesterday. Talk about key features of logarithmic functions and graphing logarithmic functions. Okay, so I'm going to start, and we're not going to do every single one of these because of time, but I'm going to start on the back of this. Okay, and we are going to basically apply, oh my goodness, who is trying to get in now? Okay, so we're gonna apply our knowledge from exponential functions and our new knowledge about converting exponents to logarithms to try to solve some of these problems. So we're gonna do number 1 together, okay? So number 1 says carbon 11 decays at a rate of 3.5% per minute. Assume that 100% is remaining at time 0 minutes, okay? So when we start at time equals 0, we have 100% of our carbon 11. Okay, this is talking about radioactive decay, right? So because it's decay, our general function that we're filling in is going to be y equals a times 1 minus r to the t power. Okay, so that's how we're going to set it up. We need to identify our f, our I, our r, and our t for this problem. I'm going to write them out to the side. Okay. Our final value here, they don't give. It's kind of asking what percentage remains after a minute. So I'm going to write it as a y. Our initial amount, they don't really give either. So I'm going to call it C sub 0 or C naught if you take physics. Our rate was 0.035. Okay, that came from here. And our time will be. Okay, so those are our values for this. So first I'm going to write out my equation for this particular problem. So y equals C naught. This is just going to represent our initial value, whatever it is, times 1 minus 0.035 to the t power. Okay. Now it asks what percentage remains after 1 minute. So 1 minute is going to give us the value t equals 1. So I'm just going to sub that into this function. So y equals C naught, our initial amount.
Wait, miss.
Yes.
I have a question. So what's the C0 mean? What does that stand for? Because it's just lagging a lot, so I couldn't understand.
Okay, so C sub 0 is going to be our initial amount of carbon. They don't give us the initial amount, so we're using a variable to represent it.
Okay, and every time we use any variable and then you just put to the 0.
Yeah, and like the 0 usually means initial.
Okay.
So altogether, it's the initial amount of carbon.
Okay.
Good question. All right, now when I subtract 0.35 or 0.035 from 1, I should get 0.965. Okay. I'm going to sub in t equals 1. So I'd have y equals c sub 0 times 0.965 to the first power. Okay. And this means that I'm going to have 96.5% of my carbon left. So 96.5% of my initial amount. Okay, and that 96.5 came from our rate right there. Let me rewrite this. Okay. Then it says write, the expression that we came up with here is just going to be rewritten here. Okay, that's all they want there. And the half-life means